What if I told you that a huge part of engineering is really just the art of tracking energy, where it comes from, where it goes, and how much of it you can actually use? That is thermodynamics. And even though the word sounds intimidating, the core ideas are surprisingly practical. In fact, if you understand just a few key concepts, you can make better sense of engines, refrigerators, power plants, batteries, heat exchangers, even why your laptop gets hot. So in this video, we are going to break down the 5 most useful ideas in engineering thermodynamics without drowning in equations. And by the end, you will see why thermodynamics is less about memorizing formulas and more about learning how the physical world keeps score. First, every thermodynamics problem starts by asking, what am I looking at? That is the idea of a system. A system is the part you care about, maybe a gas in a piston, steam in a turbine, or coolant flowing through a pipe. Everything else is the surroundings. Why is this useful? Because once you draw a boundary, you can track what crosses it: heat, work, and mass. That single move turns a messy real-world situation into something you can analyze. For example, in an engine, fuel enters, exhaust leaves, heat escapes, and work comes out. If you do not define the system clearly, you cannot tell what is happening. Second, energy is never created or destroyed, it only changes form. That sounds basic, but it is the backbone of engineering design. If a machine loses useful energy, that energy did not vanish. It got converted into heat, sound, vibration, or some other less useful form. This is why engineers care so much about efficiency. A car engine, for instance, might burn a lot of fuel, but only a portion becomes motion. The rest becomes heat in the radiator and exhaust. Understanding this helps you improve performance, reduce waste, and manage temperature. Third, not every energy change is equally easy to reverse. That is where entropy comes in. A simple way to think about it is this: entropy helps explain why some processes happen naturally and others do not. Heat flows from hot to cold on its own, not the other way around. A cup of coffee cools down, but it never just reheats itself in a room. Why does this matter? Because entropy tells engineers how much of the energy is actually available to do useful work. This is huge in power plants and engines. You cannot convert all heat into work, no matter how clever the design. That limitation is why turbines, compressors, and refrigerators have real efficiency ceilings. Fourth, thermodynamic properties like pressure, temperature, volume, and internal energy tell you the state of a system. And the state matters because once you know enough properties, you can predict what the system will do next. This is especially useful with fluids. For example, steam at high pressure and high temperature behaves very differently from liquid water at room temperature. That difference is what makes steam turbines work. Water is heated, turned into steam, expanded through a turbine, and then condensed again. Knowing the state at each step lets engineers design the cycle efficiently and safely. Fifth, real systems are never perfect. Friction, pressure drop, heat loss, turbulence, and irreversibility always show up. This matters because idealized calculations are useful, but only if you know how reality changes them. For example, in a heat exchanger, you want heat to move from one fluid to another as efficiently as possible. But if the pipes are poorly designed or the flow is too slow, you lose performance. That is why thermodynamics is so powerful. It does not just tell you what should happen in an ideal world. It helps you understand why the real world falls short and how to improve it. So if you remember just 5 ideas, make them these: define the system, track energy, respect entropy, use properties to identify state, and never forget real-world losses. That is the heart of engineering thermodynamics. Not just formulas, but a framework for understanding how machines, fluids, and energy actually behave. And once you see it that way, a lot of engineering suddenly starts making sense. Engineering thermodynamics explained. The 5 most useful ideas every engineer should know is just one small part of thermodynamics. If you are interested, our full free thermodynamics course is linked in the description.